Alright guys, welcome to the stroopwafel session. As you can see, there's some stroopwafels around. If you don't have any stroopwafel, please raise your hand. There are people that still have some in the back. Do we still have those stroopwafels in the back? I got some extra bags, so feel free to share. Oh, you got one or not? You need it? Okay, let me get it all the way over there. There's one reason why you would like this session is because of these amazing stroopwafels. I explained just a minute ago. We use them as for login VSI as a gift, you know, for our customers and stuff like that. So I had to taste them for 1 week. And these are truly the best stroopwafels you can get in the Netherlands. They're made by angels, so I hope you enjoy them. But I'm not here to talk about stroopwafels. I'm here to talk about Windows 10. So, just a question. Who of you already deployed Windows 10 in the VDI environment? 1, 2, 3, 4. Okay, cool. Who of you is doing it on Citrix? Can you raise your hand? Who are Citrix folks? VMware folks? Only just a couple of hands. Who is using the VMware View OS optimization tool to tune their image for Zen Desktop? Only a couple of hands. You're in the right location, I hope, in this session. We've been, I'm Jeroen van der Kamp. I'm the Chief Technology Officer for Login VSI. We've been doing testing and tuning of Windows and VDI for a very long time. Maybe you know me from Project VRC. Ruben and I started that many years ago. We did many publications on best practices and stuff like that, how to tune the performance of VDI environments. We learned a lot of new stuff. And then Windows 10 came around. And we decided, like, well, so how's Windows 10 performing? And we did some initial research and we really figured out that if you come from Windows 7 and you move to Windows 10, there's a lot to be learned. There's so much more tuning and so many best practices maybe don't even apply anymore. So in this session, we're going to discuss Windows 10. We're going to discuss how we test it, because we will swamp you with graphs. We have way too much information, so probably I will go through it very, very quickly. We also did a preview on the Windows 10 results and comparing Windows 10 actually with Windows 7, which is very, very interesting. And then we move forward on VMware OS optimization tool, and I'll explain later what it is and why we really, really, really like it. And then we're really going to deep dive into performance tuning. There's a question already?
Which version of Windows 10 you're using?
We tested so many versions. So we tested the first version, and now we tested, this one is on the...
So I mean the legacy, the one, or the...
No, not the, no, so I'll explain. Yeah, but the current business branch we tested.
Okay.
Yeah, it's a very good question because I want to discuss this. So we talk about testing Windows 10, right? And Windows 10 is a very big deal. The short version is I like Windows 10 because basically Microsoft fixed all the things they did wrong with Windows 8, right? And I think we all agree. I think the far majority of organizations skipped Windows 8, they stuck on Windows 7, and now we really see there's a lot of interest in Windows 10. It's really driving the market. We are all engineers, you know, it's our bread and butter business, and I was so disappointed with Windows 8 because there was clearly no influx for new projects based on Windows 8. It was really, really low volume. And now with Windows 10 it's good for us because people are way more enthusiastic about it. The thing is, these are 2 generations of Windows. So coming from Windows 7, the difference is pretty big. Actually, it's not just from a feature point of view. The whole way Microsoft delivers Windows 10 is fundamentally different than we're used to. And one example is that we now can choose, and thank you for that little bridge, is that we can choose between the long-term servicing branch, which is a stripped-down version of Windows 10, or the current business branch. So I have a question. Who is deploying the long-term services branch in VDI? I'm surprised, to be honest. I'm surprised. See, only one hand waving. Because it's already stripped. It's basically everything that's fluff in that version is stripped. But there's one reason why I don't like the long-term services branch, and I was wondering if you're naming the same reason as I am, you actually get a whole package of stroopwafels. Why is it not a good idea to stick with the long-term servicing branch in VDI? Why is the current business branch probably a better choice?
Yeah, no features are coming.
No features, but what specific features are really critical to any organization?
Well, edge support.
Security. So, I didn't word. So, the next question there will be stroopwafels. Well, you get those. You deserve it. Can you get it?
Yeah.
This is yours, stroopwafels. You can get it afterwards. So, think about this. There's so many vulnerabilities in Windows. And one is to pass the hash one, right? You need only 5 minutes to become administrator, to become domain administrator. This is fixed in the next release of the current business branch. And this means apart from making our users happy with all the new features, which is a pretty important thing, the current business branch is definitely the way to go. There's one problem with the current business branch. There are so many features in there that you don't need in a VDI environment. So let's start deep diving. Who of you don't know Login VSI? Has anyone never heard of Login VSI?
You never heard?
Yeah, I don't know. I have no idea what it is. Can somebody explain this? So I'll skip a couple of slides, otherwise I'll bore you to death. So when we compare Windows 7 with Office 2013 to Office 2010 using Login VSI, we can see the fundamental difference it has in total capacity. And that's what we're doing in this presentation. So what we'll do is we'll make either comparisons between Windows 7 and Windows 10 and see how they compare from a capacity point of view. We'll definitely also deep dive into the system metrics like CPU utilization and a lot of I/O information. But overall it's very interesting to see how these differences ultimately affect session density. And not just this, not just Windows 7 versus Windows 10, we're also going to figure out and try to find what is the impact of specific tuning. Well, I've been sitting in the back and I realized that this screen is already really small and that screen is really, really small. So most of you won't be able to read it. You will be able to get a copy of the PowerPoint afterwards so you can really dive into the numbers. I apologize if you cannot read it because it's really, really small information and a lot of details. So, how did we test? We did test on regular server hardware. There's no need to really elaborate on this. Regular server hardware with local flash storage. We did use the knowledge worker workload, which is the go-to workload if you want to test with Login VSI. We used 2 virtual CPUs and 2 gigs of RAM per VM. Sometimes we change this. We used for Windows 7 and Windows 10 the 64-bit version. Office 2013 was always used. We used the 32-bit version. Of course, we patched everything. This was a couple of months ago, but we patched everything to the latest level. And we used Internet Explorer 11 because Edge doesn't have a real high enterprise adaptation yet. And also to be able to fully compare. Very, very important is that the performance impact that we show you is in the real world probably higher because we are using stateful VMs. And as you know, if you're running provisioning services in a stateless environment, performance tuning becomes even more important because otherwise you get all these jobs that rerun every time you load this stateless VM. So we're using stateful VMs and local profiles. So the information that you see is probably a best case example, especially if you compare it to stateless environments. We always automate our test. We always run the test, every test, specific configuration 10 times. The reality is that we're really loading up the system, and by just doing it 10 times, you're certain that you have valid information. You can get good averages. We always reboot, of course, between the tests, and because we're running all the tests on ESX, we wait for 15 minutes to have ESX idling out. And that once the test is started, there's no background processes happening on hypervisor level. Also, the majority of tests are executed, not all, because we also test with RDP and PSRFP, as you will see, but the majority of tests were tested in direct desktop mode. You can do a VDI test without a remoting protocol. So all the difference that you see then is purely the differences on the operating system level. This means that if you're a Zen desktop user, all the information here is very much applicable to you. So we, in November, I think October, November, we published a preview. We did our initial analysis. And the conclusions from the preview still apply today. So I'm still going to share. Let's compare Windows 7 to Windows 10. when we compare Windows 7 and Windows 10 with the default install without performance tuning, so running it in VDI without any performance tuning, and we do a comparison, it's very interesting to see how extremely similar both operating systems are. So if you look from that perspective, Microsoft did a pretty good job. Without tuning, both Windows 7 and Windows 10 are almost identical. So if you look at processor time, this is the total processor time on the ESX or on the host. They're pretty much identical, no big differences. If we look at the total commands, not a lot of differences. There are differences, but not a lot of differences. However, when we look at the reads per second, IOs, the read IO per second, you can see the orange one, that's the top one, that's Windows 10, actually has a higher read profile. When you look at the throughput, because we always focused on IOs, right? But throughput also says a lot. When you look at the throughput, you can see the same difference. When we look at the writes, you can see that actually Windows 10 starts out lower, but grows grows higher. The more use you have on the system, it actually will increase. So the growth curve with more use on the system is higher for Windows 10. Very interesting. And then if you look at the throughput, your throughput on writes is much higher with Windows 10. I'm not hoping that you run this configuration in your VDI environment, right? This is without tuning. So we did a similar test, but then fully tuned the images. Oh, by the way, overall, the VSI Max difference, right? Office 2010, Office 2013, Windows 7 versus Windows 10. Windows 10 has about 12% lower session density overall in comparison to Windows 7, without tuning. Not a real world configuration, but interesting to understand how they delivered Windows 10 out of the box. Okay, time to tune the image. And you have to realize that we did this back in November. We were still very much learning. So we got all the best practices we could find from the internet, but there are many things we didn't know how to tune. So we were really like in a learning experience. And by the way, this is very, very interesting because we broke the image way more times than we actually performance tuned it. So it's also a lesson to be learned here that you really need to be careful with tuning because it's so easy to break the image. But we tested fully tuned, and again we're going to compare Windows 7 to Windows 10, fully tuned. For Windows 7 tuning, we did all the regular stuff that you do. So you disable unnecessary boot features, we disabled Windows services, we disabled scattered tasks, we disabled Windows components, we did some registry tuning, etc. And of course you do the NTFS last access timestamp, we disable that. The typical tuning that we're used to, right? Most of us know how to tune Windows 7. For Windows 10 the list is a little bit longer. And it also shows, like, if you look at the amount of services that we disabled. By the way, currently we disable way more services, but these were the services that we disabled for these tests. So the list is twice as long. Scheduled tasks, this is not complete, this list. We have 40 scheduled tasks actually that we disable. Disabling Windows components, also that list is twice as long. Removing the AppX applications, we call that AppX applications. These are the universal applications that are located in the App Store. Really worthwhile to disable them, and I'll be showing you later, but it's a very long list of things that we actually removed from the operating system. And then we did also additional stuff. Also, for instance, removing OneNote from the AutoStart. Really worthwhile to do this. So, when we fully tune the images to the bone with the best practices from November, because we're going to improve on this, but you can already see that when we fully tune Windows 7 and 10, 10 has a higher utilization overall than Windows 7. So Windows 7, from a processor point of view, can be tamed much more than Windows 10. If you look at the total I/O, fully tuned, and we were like a little bit flabbergasted, Windows 10 actually has twice the I/O total per second. Very big impact. When you look at the reads, clearly high, the blue line is Windows 10, clearly high, fully tuned. Writes, same story, all over the place, more than twice the amount of writes, fully tuned. And then the megabytes reads per second, and the megabytes writes per second, also twice as high for Windows 10. But interestingly, if you have enough I/O capacity available, the overall impact, because we're using flash storage, right? So we have plenty of I/O capacity. Overall, the performance impact is that you have 12% lower density of desktop sessions that you will be able to run in your VDI environment. Where's my coffee? There we go. So that was the initial discovery, right? So Windows 10, Windows 7, the difference is not dramatic, but the conclusion for us, like, there was some weird things happening. First of all, when we started tuning, is that Windows 7 really can be tamed, and Windows 10 was a lot harder. This is a beast, it was quite a, how to say that, an animal when it comes to performance tuning, and it doesn't listen that well to the tuning overall. It's also very, yeah.
But you had 10 years.
I had 10 years.
To tune Windows 7.
Yeah, we had 10 years to tune Windows 7, exactly, that's true. Interestingly, overall it means that Windows 10 is not that bad, but you really have to think about it. And the conclusion back then, and still today, is when you are moving to Windows 10 and you are already contented on a storage level, so you have still shared storage, or you know that you don't have the I/O burst capacity, you really need to reconsider your storage infrastructure, because Windows 10 is not an operating system that likes slow storage, and your users will also won't like it, because their experience with Windows 10 in the rest of the world is running on Flash. It's something you really need to consider. But let's do a deeper dive. And like I explained, when we did this testing, we figured out, like, holy mackerel, there's a lot of things to be learned. And we were a little bit like, where the hell do we start? Because there are literally hundreds of settings to be tested. To be tuned. So we did our own scripts, we broke the environment, stuff like that, and then in January, VMware released a tool called the VMware OS Optimization Tool, and they updated their template for Windows 10. That was the first version. So we applied it in our environment, and we're literally blown away by the numbers that we get. It's much more stable than the tuning that we did. We had no issues, almost no issues with the tuning, and we get very solid, decent numbers in tuning the image. And that's when we decided, okay, this is so good, let's figure out if we can really understand what's happening underneath in the VMware OS Optimization Tool, and understand what is the impact of specific tuning by using the VMware OS Optimization Tool. Some of you don't know it, so I have to quickly show it. It's free. Oh, I already have it running, but let me boot it. You need to run it, of course, as an administrator officially. The resolution is, well, crap. From a functional perspective, it really works. The UI is not that great. It has trouble rendering on lower resolutions, and if you do, higher font type, set to 200%, it will not render that well. You can load a template, and then you say analyze, and there are hundreds of tuning settings in here. And then if you have a good resolution, well, you hardly can see it, but as you can see, well, so just you see it has trouble rendering, but it will show you per category, it will show you what you have tuned and what you can tune. By the way, big pro life tip, if you're running VMs on your, who's running Mac? I don't see Macs, so hardly any Macs. If you want to tune your virtual Windows image, also a great tool for that. Be very careful, because it will also disable a lot of features you need in a laptop environment. But it's great to tune your image. So, as you can see, well, you can see a fraction of it. There are hundreds of settings you can analyze, and it will do a recommendation. And if we collapse the tool, and you can see there high key current user settings, high key local machine, features to be disabled, visual effects, scheduled tasks, disable services, OneNote, UAC, improve logon times, remove applications. Pretty impressive. Hundreds of settings, it will show you what you've configured and what not. So, we tested this tool, we started testing, and let's find out how good this is. So here you get a little bit, you can see the graphs, it will show you the blue ones are tuned, orange is not tuned, so this is already run in a fully tuned environment. And by the way, now we're going to really deep dive into the results. So instead of graphs, I will give you average numbers for performance graphs. So instead of graphs like this, and sometimes the differences are really small, what we did, we took a specific time point, we took the average of this, and that's what we're showing, so that you understand that you're now, I will serve you with a lot of graphs that are a little bit more detailed, but you get bar stats. So, what's the impact of tuning with OSOT? By the way, we tested it with PSU over IP to get realistic numbers. VSI Max, I apologize, fully tuned, no tuning is on top, it's the orange bar, it's 100%. We have 143, 144% higher VSI Max. So by using the VMware OS optimization tool, we got 44% higher user density. Average utilization time for processors, so for the VMs, went down by almost 30%. But now it becomes interesting because these are all I/O stats, so total I/O, average I/O per second reads, average I/O per second writes. The throughput, you can clearly see it's also higher. Some of you have seen the VDI Like a Pro presentation, but when you didn't see the presentation, why, when we fully tune Windows 10, do we get a higher I/O profile in comparison to Windows 7 fully tuned? Why? Oh, sorry, in comparison to the default installation, I apologize.
But you have more machines, no?
No, not more machines. No, this was tested at the same amount of machines and the same amount of time in the test. So we specifically did this test, making sure that there's not more machines. So we tested at the same machine level from I/O perspective. Otherwise, you get really weird results. It would never make sense. So, like, these are the smartest, simplest people in the world, right? Be honest, if you haven't seen a video like a Pro presentation, I have one more slow path effect. Caching? Nope. Why?
You also disabled some smart optimizations from Windows?
We're getting close. Which one did we disable?
Superfast.
And almost close.
Search.
Superfast. Memory compression, guys. And by disabling memory, you have to share the packet. Do you mind? So memory compression, and I'll explain later. Here you go. So fully tuning Windows 10 doesn't mean you get a lower I/O profile. Think about this. So let's dive down into these settings, and it's a lot of information. I will rush through it. I can imagine that you have some questions. If it's really not clear, please ask me. If you want to dive deep into the information, ask me afterwards, because I have only 16 minutes left and I have way too many slides. So the first thing that we did is actually figure out the HiveKey current user tuning. So these are all settings that are done on a current user level. These are, well, user tuning, like I would like to call it. There's two sections, so these are just samples of the settings that we do. The most important ones is that we actually tune the visual effects. So when we review this, and what we did is actually, this is how we test. We test fully tuned, then we do additional tests where we enable the tuning. So we disable the tuning, or we don't tune it, to fully understand the difference of that specific portion, right? So actually we did 3 tests, because if there's one setting on a visual effects level that you probably don't want to tune, it's ClearType. If you really want to make your users feel like they're in the 1980s, yeah, disable ClearType. It's just not a good user experience. So we specifically only enabled ClearType for a test, and then we also tested all the other current user settings. So VSI Max went down, the orange bars with only ClearType disabled, went down only by 2%. So ClearType is not a bad thing from a session capacity point of view, and you have very happy users. So not all tuning is always a good thing to do. When we disable when we don't tune the user settings, we'll go down by VSI Max by 5%. Deviation, that's a new one what you see, because we run the test 10 times, we can also see how much deviation was there between the tests. And deviation tells you how stable, how good and stable user experience is there in that environment. So the lower the deviation is between the tests, the better overall consistent user experience that you get. It's very clear that there's also a big difference in there. Utilization time, well, we don't tune use settings, actually you go up. The CPU goes up by 20% and you can see the I/O profiles also going up. Lesson to be learned here, tune the user environment, of course. Don't tune ClearType, I don't recommend at all. But there's also another thing here. Don't rely on OSOL to tune your user settings, because how does it work? It will tune the default user of the local profile of that image that you created. So only users with a new profile coming to that VM will get those settings from default user. So what do you need to do? Get VMware UEM, REST, whatever, logon script, get those settings in absence, REST, doesn't matter, but make them user settings and tune them on a user level so they're always applied, no matter if they have a profile or not. Don't forget. Local machine settings, we also tested. There's a lot of configuration things in here. Some things are just to make sure that the VM is working okay in a VDI environment. We tested this, and as you can see, it hardly had any impact. Is that a bad thing? No. You know, sometimes you need specific settings that are not performance related, but whatever, stability or whatever reason. So overall, HQLM settings were not that interesting from performance impact. Then we tested disabling all the features. So we disabled all the features, that's how they call it, that section. As you can see, VSI Max is a little bit higher, 2% higher, but the I/O profile CPU is roughly the same. So again, it does have an impact, but it's not that big. I guarantee you the impact will be bigger if you're memory contented. Because what you basically do by disabling those features is also use less memory. And using less memory is only an advantage when you're running out of memory. Right? If you have an 8 GB VM or 64 GB VM, running only Office without any memory contention doesn't have performance benefit. Only when you run out of memory, you will benefit from having more memory and have performance difference. So then we tuned the scheduled tasks. Very important to do. The worst thing that can happen, especially in a stateful environment, is that all your VMs are doing defrag at the same time, right? That's the worst case scenario, or a antivirus update. I've literally seen an EMC environment of 20 million euros die because McAfee was having a scheduled update, did a download of all the antivirus agents in there, and then did a full scan. And they couldn't normally boot anything anymore. They even had to reset the EMC storage. So scheduled tasks are the little devil that can bite you in places that you don't want to be bitten. But if we tested it with VSI, there's not a big, huge performance impact. Then we tested disabling services. This story is a little bit more complicated because we did it in two ways. First, of course, the gray bar is also full, so all services are disabled. When we test orange, we disabled only indexing, Defender, we disabled only these core services. And then those were disabled. And then we test with all services not fully tuned. Because we want to figure out, like, is indexing, Defender, and WSUS superfetch, those are really critical services. Are they, what is the impact of those? Because those are the usual services that you go to. And we want to understand what is the impact of all these additional services that you tune. And you can see that it's quite a big of an impact because VSI Max goes down by 20%. Actually, these services have almost a 15% overhead. So disabling all the other services only have a 3% impact. Then we disabled OneDrive. And you can see there are some differences here, and VSI Max is a little bit lower. In the real world, it will be much bigger. Because in our lab, we didn't have an internet connection. And what happens with OneNote, it will go online, you will authenticate, get an internet connection, it will continually scan for updates and stuff like that. It can have a huge impact. So OneNote can truly be a big performance killer in the real world. Sometimes you cannot see some things in the lab, especially when we don't have an internet connection. Then we disabled, did the section improving the login times. So that's, if you're running in a PVS environment, you know what I'm doing because we're disabling active setup. Huge impact. If you're running in a PVS environment, we know this, right? So this was as like expected. Then we removed the AppX applications. And what was interesting is that we tested in a little different way, because we found out that these AppX applications have an overhead, but the overhead is much more magnified if you're running out of memory. So we deliberately configured a test with less memory, just to prove that AppX can have an overhead. So the orange bar is tested with fully tuned, and we also have deleted all the AppX applications. And the blue bar is fully tuned, but we enabled all the AppX applications. And as you can see, VSI Max goes down by 5%. Real world numbers for AppX applications are way worse, 10, 15%. Why? You have all these widgets in the start menu and running in the background. What they do? They go online, they're going to check for new information and stuff like that. They're going to monitor your behavior. And as a result of that, you can expect by disabling these applications, you will actually in the real world will improve performance way more than just in our test lab, where we had no internet connection and these AppX applications couldn't do anything. The visual effects. Well, we tested this. This was an old template. And this is funny because you tuned it, but the only thing it did, it configured the visual effects for the user account that you were using while you're configuring the image, which is bonkers. So they also removed it from the next version of the template. Okay, so let's talk about superfetch, prefetch and memory compression. Because it has a huge impact. So we just had a discussion about it, and it is one of really interesting feature. Because you actually have a choice. If you're running Windows 10 and you're contended for I/O and throughput on your storage, so there's a problem there or a potential problem, you might consider enabling this feature. Because what happens if you enable? By the way, we didn't individually test superfetch, prefetch and memory compression as separate features. Because they are all locked into each other. If you disable the prefetch, superfetch service, it will disable also all the other features. We're looking for next publications to find out specifically what all three individually do, but it's pretty difficult to disable them individually. So we tested, and the impact on the VSI Max, so we tested with prefetch and superfetch enabled, and the rest is fully tuned. You can see VSI Max goes down by 7%. But there's a huge trade-off, because you can see total I/O profile goes down dramatically. Your read I/Os almost halves, and your write I/Os almost goes down by 30%. So maybe it's a better choice to leave it enabled in your VDI environment. If you have like Atlantis, Nutanix, you got hundreds of thousands of I/O per second per VM available, you don't care about it. Of course, you have plenty of I/O capacity, that doesn't make sense. But if you're contended for I/O, please think about consider maybe it's the best practice for you to enable it. Because, I rather have a little bit less CPU capacity than having not enough I/O capacity, because that will completely blow the user experience.
But you have 6% less machines
Yeah.
for half of I/O. Okay, or 40% less I/O.
Yeah, because in our environment we don't have an I/O bottleneck, it was a CPU bottleneck. As you can see, CPU went up by 4%.
Okay.
So the price that we pay to lower the I/O footprint by enabling prefetch, superfetch and memory compression is higher CPU footprint, lower amount of sessions, because that is our primary bottleneck. What we did Well, health, the I/O profile.
No, I will say from this feeling what I see when I see this, I will go with on. Even if I don't have a bottleneck.
That's your choice.
Yeah, okay.
Yeah. I agree, that's your choice. We also did testing some other stuff. I only have 4 minutes left, so I'm going to fast forward. We tested Windows 10 Defender. You know that we published white papers, white on tuning antivirus, my favorite topic. Not. That was really the hardest white paper we ever did. The outcome of that white paper was that Windows 10 Defender actually was pretty good from a performance point of view. Really impressive, to be honest. If you compare that to the other AV scan, they had a much bigger overhead. More importantly, I don't recommend Defender because we all know that Defender is probably the worst AV agent out there that blocks least of the threats out there. So there's a double-edged sword, but at least we have something, and we did investigate. We tested with a pre-scan of the image and without a pre-scan of the image, and all best practice was to always do a pre-scan of the image. But as you can see, we did 10 test runs, averages, and we tested with pre-scan and without a pre-scan of the master image. So we do a full scan of the master image before we deploy it. Doesn't make any difference. Why? We're running in a stateful environment. So once you've run the test, once the executable is hashed, it will be cached for the next time the executable is launched. In a stateless environment, please do still do a pre-scan. But overall, the performance impact of Defender is 4%. Office 2013 versus Office 2016. Also one of our favorite topics where we published about, right? The reality is that you lose almost 20% of capacity because CPU, so Office loves CPU. And I have bad news because Office 2016 doesn't improve anything. There's no way to tune this. We really want to deep dive into this. I know that the Office team is aware of this, but still the reality is if you move from Office 2010 to 13 to 2016, make sure you get plenty of more additional capacity in your VDI environment because it will eat your CPU and it will love your storage. But the interesting thing is that the OSOT tool has templates. We can create our own templates. It's really rather easy. You can do it via the interface. And actually that's what we did. So we created the VDI like a Pro template because we relied on the OSOT tuning and we did all the testing there. But we have also a lot of other tuning and we go even one step further. So how much can we do? So I show you, I hope I choose the right one. As you can see, I choose a template and collapse everything. Here we go. So there's a VDI like a Pro section with all kinds of additional tuning. I have no time to dive into the details, but as you can see, there's quite a few settings that we found. We're figuring out, like, if we test this, how much more performance do we get? So we get back to our little presentation. So OSOT default is orange. And actually by using the VDI like Pro template, we gained 4% more VSI max, so we gained capacity by 4%. And you clearly can see that the I/O profile went down by average about 10 to 15%. So it's still worth to do extra tuning. Maybe you say, like, I don't care about 15%, but 15% of an infrastructure carve out, you know, if you spend 1 million on the infrastructure, 15% is 150,000. Or maybe it's just a little bit of extra capacity that you need in peak periods. So I really believe in tuning and the importance of tuning, of course. Representatives. So do we have recommendations? Oh yes. Please start using the VMware OS optimization tool. Also when you're a SanDisk user. There is no setting apart from disabling the VU client, and that's not in there anymore because that's not the best practice anymore. Really use it. It's free, download it from the internet, you can find it via Google. The VDI like a Pro template is available from our website. You can just download it. Think about stateful versus stateless. The numbers that you've seen are more extreme in your environment if you're running provisioning services, for instance. One thing is really important, please consider not to tune always everything. The worst thing that you can do is immediately tune everything out of the box. Think about what your users need. Do you really want to disable indexing? Do you really want to disable Defender? Do you really want to disable clear types? Yeah? So you need to make your own choices. CPU will become your main bottleneck if you have enough I/O, but if you don't have enough I/O capacity available, that will become your first bottleneck. Oh, I didn't talk about it, just a little PS. Who of you always runs a check disk before you deploy it in PVS or whatever? Now all the other ones are going to do the same thing.
1 minute.
Yeah, thanks. So please, I didn't talk about it, but one thing we learned is we got in so much trouble because we didn't run a check disk. You think, how can it break when you just move the image in view, whatever? It can. So before you deploy it, run a check disk. It's a golden best practice that saves you a lot of trouble. And the most important best practice, of course, is start testing yourself. We learned so much, but the problem is we only focus now on Office 2013 and just default applications. In your environment, with your antivirus solution, with your applications, with your infrastructure, with Citrix, with tuning, stuff like that, you will find different results. You will learn. If you just go roll out Windows 10 into production and try to figure it out later, the problems, that's not a smart strategy. So we really recommend that you test yourself. I think that's it. 1 minute over time, no more slow paths left.
3 minutes over time, but that's okay.
All right. Did you go back? Did you look at the 2012 template? Is that a good?
You will be here
example of-
entire weekend. And
So, no more questions.